Hey everybody, Mr. Bowman here. This video is on 2.12 probability methods and it focuses on all the merit questions for the 2024 exam. Just a reminder, these are all past NZQA paper questions. I've just kind of compiled them and put them all in one place for you. So if you're wanting to find out or to find more merit questions in relation to the standard, please check out the link in the description and you'll find all the other ones there. So let's have a look at question number 41. So question number 41. We've got a sports survey. They've been asked how many hours per week they participate in physical activity, either sport, PE, exercise, or fun, whatever it might be. The results have shown a mean of 10.8, a standard deviation of 3.2. I'm loving this language because straight away I'm thinking, well, it's going to be probably normal distribution, right? Assume that it can be modeled by a normal distribution. That perfectly confirms what we've been doing. And then the question itself, 12% of all young people have found to do less than the activity that the Ministry of Health and their guidelines recommend. What is the minimum number of weekly hour exercises they need to meet to do this deadline? So basically, we know that the bottom 12% of students, let's actually draw a normal distribution curve, the bottom 12% of young people, whatever the survey is about, so that's this group here, this 12% shading it in, 0.12, they are below the ministry guidelines. The issue is they didn't specifically tell us what the X value for that guideline was. So that's what we're going to do now. We're going to try to figure out this minimum number of hours to meet the guidelines. So this is going to be an inverse question because we've been given the mean, right? A mean of 10.8. And we've been told the standard deviation is 3.2. So that means we can plug this into the inverse normal distribution mode on the calculator. And I'm just going to write down my calculator inputs for that. So my tail here is a left tail. And we can see that. And that's because the shaded area is on the left-hand side of my curve. My area, the area relates to the probability you're given. So that's 0.12. We've been given a standard deviation of 3.2. And we've been given a mean of 10.8. So when I plug that into my calculator, that's going to give me X, which is going to be that number over there. And that there was 7.04 hours per week. Now, the issue with these merit questions is sometimes it requires a contextual link to make sure you get in your full mark. So for these merit questions, particularly the inverse ones, put it in a sentence form to make sure you're getting the full marks. So let's write that down. So young people need to do physical activity and I'm going to just round this to 7 hours because it's so close to 7 hours, of 7 hours or less to not meet the Ministry of Health guidelines. So Ministry of Health guidelines. Oh gosh, I have a nightmare with the spelling today. Ministry of Health guidelines. Okay, so pretty cruisy merit question. Hopefully it's these inverse normal ones, the ones you're confident with, just to make sure you're getting all those easy merit marks that come up. So we're now on to question number 42, and luckily in this graph, in this year, some of the trees were given to us, which just saves us a great amount of time, so a big fan of that. So let's break the question down. So you can see if a lot of the trees here are missing, so I guess we need to keep an eye on that information and pull them out. So we got learning a second language is to be considered a good way to improving memory, also found to help dementia or help prevent dementia in your later life. So perfect, 2 good reasons to learn another language if you're not. We've got approximately 22% of the users were under 18, so that's the number we're given here. 35 were 18 to 30, so that's actually going to be that number there, right? 0.35, and the rest were there, so that's going to be 1 minus those 2 numbers, and if you do that, that gets you to 0.43. So I've kind of dealt with that information there. Of those who are under 18, so we're dealing with this under 18 part of the branch, 3/4 were using the app, this language learning app, for academic reasons. That's the 3/4 there. 15% for travel. So let's write that on the travel branch, 0.15. Done that. And the remainder for personal reasons. So I suppose we should note 3/4 is 0.75 plus 0.15 is 0.9, which means the remaining bit there must be 0.1. So I've now dealt with that information there. For the app users that were 18 to 30, that's this kind of next chunk here. 1 and 4 were academic purposes, so that's 0.3 or 0.25. 60% were to prepare for travel, 0.6, which makes sense because most 18 to 30-year-olds aren't in school anymore, and the other were for personal reasons, so it's going to be 0.15. So it's 0.15. Okay, now let's get to the actual question itself. Out of a randomly selected group of 40 users, how many would you expect to be aged between 18 to 30 and using the app for either travel or academic purposes? So basically, we're trying to find this group here. What's the probability of this group here, the 18 to 30-year-olds for academic and travel purposes? And then once we've got that, we're going to use an expected formula. So expected number formula, which is, remember, n times p, to find out how many of that group of 40 we would expect to be in there. So I suppose let's find out the probability of these two branches here, right? So those two branches, we'll call that branch number 1 and branch number 2 for my working. So we'll do that over here where we can see it clearer. So number 1 is going to be equal to 0.35 times by 0.25. Branch number 2 is going to be equal to 0.35 times by 0.6. And I can calculate both of those branches. So that top one's going to be 0.0875. The bottom one is going to be 0.21, which means the total probability of the group we're looking for is 0.2975. So that's the probability of being, 18 to 30 and using it for academic purposes or travel purposes. So hopefully that makes sense. The notation is not really required, but it'll help me understand it a bit better. So now that I've got that, I can use my expected number formula, as I said. So my expected number, remember, is equal to n times p. N is the sample size, so our group is 40. So our sample size is 40. P is the probability of the event you're looking for. We've just calculated that there, 0.2975. And when I plug that into my calculator, I get 11.9. So it's pretty close to 12. So it could be 11, but probably 12 people we're expecting from this group to meet that criteria. So again, because it's a merit question, we've got to be careful, pop it in a sentence just to be sure that you're getting all the marks that you can. So we would expect, and you can't have 11.9, so let's go, we would expect 11 or 12 of the 40 users to be aged between 18 to 30 and using the app for academic or travel purposes. Okay, so we're now on to question number 43, and this question was quite challenging, so I actually used a bit of algebra in the end, but let's break it down, that way I can show you where the issues were. So the first statement there, basically there's a premium or standard version of the app. People who buy the premium version are 4.2 times more likely to finish the course compared to standard users. So basically what that means is if we know this probability, we can times it by 4.2 to get that probability, or we can divide by if we did the opposite. It is known about 5% of the users install the premium version. It is estimated the probability that a random standard user finishes the course is 3.8%. So because this last one here was about, if they were a standard user, they had a probability of 3.8% of finishing the course, I thought that kind of looked like a tree, right? So what I'm going to do is we're going to do premium users versus standard users, and we're going to go completed the course, not completed the course, completed the course, and not completed the course. So it's going to get a bit messy, I think. So premium users was 0.05, which means the standard users were the other 95%. So we've been told that standard users, if they were a standard user, they have a 3.8% chance of finishing that. So that there is going to be 0.038. And we know from the top the premium users are going to be 4.2 times more likely to finish the course. So that means this branch up here is going to be the standard user rate times by 4.2. And when I did that, I got 0.156 or 96. I just want to note, I should note the model answers that have been given to us by the NZQA, they've rounded this answer a bit differently, so their answers end up being a little bit off due to the rounding, but I've tried to be a bit more precise with my rounding. So going back to the question, what is the probability of someone finishing the course overall? So that's going to relate to these two branches here, right? So we could calculate this branch here, could calculate this branch here, but we don't actually need those numbers. So let's go ahead and find out what those two values will be. So that top branch, that's going to be 0.05 times by 0.196, and that there was equal to 0.0080, which had a 4 dp rounding. And then finally, next branch here, that's 0.95 times by 0.038. And when I do that, that gets me to 0.0361. And again, that had a 4 dp rounding. Just to find the overall probability, we just got to add together these two things here. So the probability of finishing the course, so I'm just going to write it up fully, finishing the course is going to be equal to 0.0080 plus 0.0361, and that there combines to 0.0441. And I want to note this answer, I thought I was wrong initially, but that answer is a little bit different to the model answers. But I want to note, just because they're rounding, they've rounded a bit earlier. I think they rounded this number here to 0.4 maybe. Something was rounded a bit weird earlier. So we're now to question number 44. And we've got a nice table. These table questions are quite nice. And this stuff here ended up actually not being too useful. But the question simply was, what is the probability they developed MCI, and you can see developed and not developed up here, if they learnt a language at least one time? So basically, learning a language was going to be this group here, right? So you're interested in these people here out of these people here. So this one here was a conditional question, which straight away means it's going to be merit. But the numbers are just going to be a bit annoying to figure out. So let's jot down my notation. So I'm trying to find out the probability that they developed MCI given they learnt a language. So learned language. So remember, I always teach my classes the F over T approach. T is the total number of people the question is interested in. And in that case, it's the two groups over here who've learned the language. So that's going to be 576 plus 124. And of those groups, or of those people, how many of them learnt the language? And that's the other group there that we've circled. So that's going to be, also of those, how many developed MCI? That's going to be 224 plus 42, so that's going to be 266 over 700, and when you put that into your calculator, I thought it was going to be a messy number, but ended up being a nice rounded 0.38. So yeah, as I said, nice easy merit question. Again, it is a merit question, so make sure there's some kind of context in your answer to make sure you're getting the full mark. So we're now into question number 45, the last merit question for this exam, and this one carried on from the previous question, but you didn't need any of the tables going in there. So we've got, I guess the key bit of information is find out the relative risk of a person developing MCI who learnt music. So in probability notation, that's probability of MCI given they learnt music for over 4 years. Versus those who did not. And then the second half of that sentence is probability of MCI given there was no music. And if you divided those together, so top number divided by the bottom number, that there would have been the 0.78. So let's start by jotting down that formula, and we're actually going to use a bit of algebra in our graphics calculator solver mode to get the rest of this question. So probability of MCI given they had music for 4+ years over probability of MCI given they had no music training. And we know that relative risk calculation, we were told it was 0.708. So now that I've got that, we've been asked clearly to find alpha, that unknown variable over there. So what would that number there be? So what we need to do is we need to form some fractions for the numerator and denominator. One of those fractions will include our unknown variable, a, and that means we can then go ahead and use our algebra or our graphics calculator to solve for a. So let's do MCI given 4 plus music. So the 4 plus music people is this kind of group over here that I'm circling. There's a total of 256 or 258 of them, and of those 258, 85 developed MCI. So that fraction there is going to be 85 divided by or over 258. And that there is going to be over the next probability, and that's probably going to include the A because we haven't used that yet. So the people who didn't use music is at 346 there. A of those 346 developed MCI. So that's where my unknown variable is coming in. So that's going to be A divided by 346. And I've got a fraction over a fraction, and we know that's going to be equal to my relative risk of 7.08. And now at this stage here, you can use your step-by-step algebra to do it. If you know calculus or you're doing calculus as well, go for it. But my advice would be to put a bracket on the numerator, put a bracket on the denominator, and use your solver mode of the calculator. So when I did that before, I got A is equal to 161.006 with some more decimals after that. But thinking of the context, because this is dealing with the number of participants, we can only really have a whole number, and it's so close to 161. So I thought, well, let's just go, well, that's going to be equal to 161 participants. And again, just noting, because it's a merit question, I've got my probability notation with my links to context, and I've also stated what my answer of 161 actually is. So that means I'll get those full marks.